Hello and welcome to AiEMA. Today, we'll be showing you how to use our powerful tool. First, log into our dashboard. Here, you can easily access your past projects or create a new one. To create a new project, simply upload your Gerber file. Upload your BOM file. And select the columns you want to import. Upload your PNP file. Select the columns and confirm the unit of measurement for your coordinate data. Once your project is loaded, it's time to take a look at the 3D simulation of your PCB. With our easy-to-use control panel, you can rotate, pan, zoom, and view the top and bottom of your PCB design. You can also switch to isometric views and layering, allowing you to see every detail of each layer. With our PCB layer bar on the left, you can easily control the display status of each layer. And even choose to view only a single layer or display all layers with one click. In the production information bar, you can customize your board specifications such as its thickness, copper thickness, and even adjust the color of your PCB and silkscreen. Next, let's take a look at the BOM matching function. Our system will intelligently match the corresponding device data based on the BOM file we uploaded. There are several matching states here. A score of 10 means a perfect match, indicating that the matched device model and brand are exactly the same as the requirement, or the code is exactly the same as the requirement. A score below 10 indicates intelligent recommendation, meaning that some core parameters are not consistent with the requirement. AiEMA will prompt us all the conflicts for reference. For this type of device, we need to look at more information for identification. By clicking the icon, we can see the specifications, device pictures, symbol diagrams, pad diagrams, 3D models of the device. Of course, we can also go to the device's details page to view and download the data sheet. If we determine that the device is available, we can change the status by clicking Confirm Model. If the matched device is not available, we can view replacement models here. There are system-recommended substitute models available here. We can also manually enter the device model or parameters to search. In addition, AiEMA provides some purchasing data, such as the price of electronic components. When we enter the number of samples and mass production, the system will automatically estimate the total procurement cost. We can also export the quotation file and operate it offline. Let's take a look at the contents of the quotation file now. The quotation file contains the content of the original BOM and the device data matched by the system. Now, let's take a look at the BOM Coordinate Management section. This module allows you to view the coordinate information for each component in your BOM. AiEMA compares your BOM file with the PNP file and identifies any anomalies. For example, the system might notify you that there is a reference designator, C75, in your BOM. But there is no corresponding coordinate information in the PNP file. In such cases, you can choose to delete the reference designator from the BOM. or add the coordinate information in the PNP file. Similarly, if there is a reference designator in the PNP file that is not in your BOM, you can edit or delete the reference designator in the PNP file. Or add the reference designator in your BOM. In addition to these features, we also support editing BOM and PNP data, adding components and coordinates, editing imported columns in BOM and PNP. Here, we have generated a PCB assembly simulation model based on the file data you have uploaded. Similar to the PCB 3D preview module, this simulation model supports all 3D viewing operations. By selecting a specific component in the view, we can see its coordinates, surface data, specifications, and other information. By searching for a specific reference designator in the list, we can quickly locate it in the view. On the left side, we have the PCB layer control area, project information, and DFM analysis function. By running the DFM analysis, we can obtain the PCB manufacturability analysis report. After running the DFM analysis function, the analysis results will be displayed on the right side. The inspection items include pin and pad spacing, chip pad size, SMT component mounting position, distance between original components. Let's take a closer look at the specific inspection results. When we open the analysis result pop-up window, the view will automatically locate and highlight the abnormal components. In the pop-up window, we can see the calculated values, reference designators, packages, surface data, and coordinates of the abnormal components. Below, there are diagrams, risk descriptions, and mitigation suggestions. We can open the result list, which shows all abnormal components for the corresponding inspection item. By clicking the previous and next buttons, we can quickly switch between them. When we choose to highlight all the anomalies, all abnormal components for the inspection item will be highlighted in the view. Let's take a look at other types of risks. This indicates that the mounting position of the SMT component is incorrect. By turning on the transparent mode, we can better visualize the error. So how can we correct it? One method is to modify the position by adjusting the coordinates in the panel on the right side. Another method is to correct the component position by offsetting the coordinates. We can start by selecting the component's center point as the starting point. The center points of the two diagonal pads as the end point of the offset. Then click the Apply button. The component will be correctly mounted in the desired position. Lastly, if you want to share this project with your colleagues, there are a few ways to do it. One way is to click the Share button on the Workspace page. You can set the sharing period, access permissions, and open modules. Generate a sharing link and send it to your friends. Another way is to generate a demo video. Download and save the video, and then send it to your colleagues. That concludes the core functions of AiEMA. Thank you for listening.